Welcome back to Quay Does Leetcode. Today I'm going to be doing problem number 19, remove nth node from end of list. So for this problem, we're given the head of a linked list and we want to remove the nth node from the end of the list and return the head. So in this example, n equals 2, so 5 would be the first node from the end, and 4 would be the second node from the end. So you need to remove that node, the second node from the end, and then return the new list. So how could we do this problem? Well, if the question asked us to remove the nth node from the beginning of the list, it would be easier because if you want to remove, this is the first node from the beginning, this is the second node from the beginning. So if you want to remove the second node from the beginning, you just go to the first node and you take its next pointer and you point it to the next pointer, and so it's next pointer, and that way you remove this node. So how could we do that given the node, the number of the node from the end? Well, we could, what if we knew the length of the list? So if we knew the length of the list, and the length of this list is 5, then to get the node that we need to be on to delete its next node, you would just do length minus n. So we would do, this is 5 minus 2. That node is the third node, which is this node. So you would just do that many nodes, the third node from the beginning, and then you would be on the correct node, and then you would just take that node and make its next pointer point to the next pointer, which would delete this node. And then there's one edge case that you have to take care of, and that's if you are deleting the first node. So if you're deleting the first node, which would be n equals 5, the fifth node from the end, if you delete the first node, well then you don't have a node before the first node. You have no node before the first node to say its next pointer needs to be next. So instead, it's the first node. So to delete the first node, you just remove, if head is here, you just make head the new head, this node. So head equals head.next, and that's how you delete the first node. So for every other node, you go to the node before it and you move its next pointer to its next.next. Otherwise, you move head to be head.next. So that's how you would solve this problem. You would first get the length of the list. Now, how could you get the length of the list? Well, you could basically traverse the list one time and count 1, 2, 3, 4, 5. That's how you get the length of 5. And then to get the node that you're supposed to be on to delete the next node, you would do length minus n. And that would give you the correct node to be on. So, and then to handle the edge case for deleting the first node, you just make the head.next. And that is essentially how you would solve this problem. So let's see it coded up. So the first thing that we would need to do is get the length. So we would start and make a length variable and start that off at 0. And then we would make a current pointer start at head. And now we're going to traverse the linked list until we get to the end of the list. So while current is not none, we're going to say our length is going to be incremented by 1. And then we're going to move our current pointer to be current.next. Now, when we get to the end of the list, our length has been incremented up to how long our list is. So now we have our length. So now we just need to get the node before the node to delete. So to get that node, we would do length minus n. And that would be, we're going to call that node I. We're going to call that the number of that node I. And so now we have the number of the node to starting from the number of the node starting at 1 to the count of the number of the node that we need to delete. So we're going to loop while I is greater than 1, because when we get to 1, so say our length is 5 and our n is 2, so our I is 3, so we need to go 3 nodes. So we're going to decrease I by 1 every time, and when I is equal to 1, then we found the node that we need to stop at. So while I is greater than 1, we're going to increment current. We're going to move current back to current equals head. And we're going to increment current equals current dot next. Okay, so now when we finish this loop, the current node that we're on is going to be the node right before the node to delete. So we have two cases. One is if our n was the same as our length, meaning we want to delete the first node. So that in that case, if our length was 5 and our n is 5, our I is going to be 0. So we have two cases: if our I is 0, if our I is greater than 0. So if I is greater than 0, if I is greater than 0, then this is our regular case where our current is at the node right before the node we wanted to delete. So to delete the next node, we're going to say our current dot next is going to be current dot next dot next. So we're going to skip the next node and we're going to make our current dot next our current dot next dot next. And then we're going to return our head. Now, if I is 0, meaning n was the same as the length, then we want to delete the first node. So if we delete the first node, we're just going to we're going to move our head to be head.next. So head equals head.next. So that deletes the head node. And then we just return head. So to shorten this a bit, we could just return head.next. And those are all the cases. So that is the code for removing the nth node from the end. Let's run it and see what happens. So we're getting the correct answer. Let's submit. So we submitted, and it's a pretty fast solution. 91%, faster than 91% of all Python 3 submissions. So that is that problem, and that is actually running in O of n time, because we are traversing the list twice, once to get the length and once to delete the node that we need to delete. So that's 2n, but that simplifies to O of n. And then for the space complexity, we are only using a few pointers, so it is constant space, so that's O of n time and O of 1 space. And I hope that was helpful. Thanks for watching, and I'll see you in the next video.